quadratics. And form number 3. The one that you'll use the most frequent is this one right here. This is the Vertex form of the equation. Now, first thing I want you to identify, what is the one commonality between all 3 of the equations? A is at the start. A still influences the start of this at all times. So you have opens up if it's positive, opens down if it's negative, opens wider if it's less than between 0 and 1, and then it opens narrower if it's greater than 1. Okay? So A still influences in all these cases. All right? In this one, R and S represent what? Roots. This equation, my vertex, is whatever H and K is. That's why we call it the vertex form of this equation. So the axis of symmetry of this guy is x equals h. All right. The maximum or minimum will be dependent on whether it opens up or down, of course, so same thing. The range in this case will be either y is greater than or equal to k or y is less than or equal to k, depending on which way the graph opens. Okay? Now this is, to me, the most efficient way of graphing is through the vertex of the equation. It makes it very simple to graph this. So let's take a look at an example. Y equals -2 x at 4 squared plus 10. Okay, so there's my equation. A is negative, therefore which way does it open? Down. Opens down, right? My vertex in this equation is what? What's your H value? Negative 4. And what's my K value? 10. So it's very similar to when we write out the equations for lines. Remember how I write this out? So just have a look at this. If I line it up directly underneath it, whoops. Okay, my A value is -2. My H value, because it's subtract, turns to a positive. That means it's subtracting a -4. That's why it's an add. And then K is 10. So that's pretty straightforward. All right. Now, if I were to ask you to graph this without the use of the calculator, I said that you need to have a minimum of 3 coordinates in order to graph a problem. So what I do is I take my vertex, that will be the first coordinate that I graph, so -4 and 10. And then I pick a coordinate to the left and one coordinate to the right, the same distance from the vertex. So in this case, I'm going to go -3 and -5. Right? Let's put -3 into this equation. -3 plus 4 is what? 1. 1 squared is? 1. 1 times -2 is? -2 add 10 is? 8. -5 plus 4 is? -1. -1 squared is? +1. 1 times -2 is? -2 plus 10 is? 8. I now have 3 points to graph. So let's So I go to -4 and 10. Let's put it up here. And then I go -5 and 8, which is right here. -3 and 8, which is right here. And I graph it. This is the easiest way in which we can graph a problem. It's using the factored form of it. So the first thing that we're going to ask you to do is graph the equations, or write out all the properties of this. So let's look at this. What's the equation of the axis of symmetry?
X is equal to -4.
X equals -4. That's that line right there. So x equals -4. Maximum or minimum?
Maximum.
Maximum. The domain.
-infinity to -infinity.
-infinity to positive.
Sorry.
Right. X is an element of all real numbers, right? So my domain, I know you guys like this, so I'll put it, but I like X an element of all reals, if that works. Okay, and what's the range on this question then?
-4 to -infinity.
-infinity to +10.
Okay, so what's the lowest it
I was
goes?
looking at the wrong one, my bad.
Okay, what's the lowest it goes? -infinity. The highest it goes? +10. Or y is less than or equal to 10. Enough?
Yeah.
So everything is still the same. The only difference is where I start the question. In this one I started with roots. In this one I started with my vertex. That's the only difference in the two. Okay? Then the next step in the whole process after you can graph it is, can you write out an equation in this form? Here. Determine the quadratic function corresponding to this parabola. So look at the top of page 199. First thing I do is identify what h and k is. What's the vertex of that parabola on 199? 7 and 8?
Yeah.
Okay, so let's put that into my equation. See it? And just like what I was doing yesterday, what's the next thing that I need to find? A. And how do I find A?
Plug that into your formula. Plug those points.
Plug A coordinate.
Yeah.
Give me one. They give you one.
4, -1.
Or -1. Okay? So they wrote it down on there. You can use the intercepts. X or Y. You can use any coordinate as long as you can see that it goes through that point. Okay, but they gave you this, they wrote that down. So now we solve it, right? So I've got A, -3 squared is 9, add 8. So I'm going to subtract 8. And then divide by 9, -1. What's my equation of that graph?
Y equals -1. X minus 7 squared plus 8.
There you go. Okay. So far, so good. All right. To me, this is the easy part. I think this is easier than roots, and I think it's obviously easier than standard. Now, one of the things that they may ask of you is to change this to standard form now. So I now need to multiply it out. So what I'm going to do first, so this is somewhat new. I'm going to do this first. X minus 7 squared is x minus 7 times x minus 7.
So x squared plus 49. Or is it still negative?
Go. FOIL.
X times X is.
Yeah.
Both sides, so X times negative 7. Negative 7 times X.
Okay? Good work. You remember how to do this? First, x times x. Outside, x times negative 7. Inside, negative 7 times x. Last, minus 7 times minus 7. So, going back to it then, I have x squared minus 14x, add 49, add 8. Okay? Right? So x squared minus 7x and minus 7x make minus 14x. Okay? And then add that in. Now I distribute through. Negative x squared plus 14x minus 49, add 8. So I times each of those by negative 1. So basically I change my signs. And my answer final, minus x squared plus 14x minus 41. There's the equation in standard form. Okay, so far? So, we did the same thing yesterday with the roots, right? You had to FOIL the roots and then distribute through in order to get it into standard form. And that's the last thing I want to talk to you about is okay? We need to be able to go from here to there as we go through these questions. You'll notice that's what they asked you to do yesterday. Find out using the roots equation. Now, given any graph, what we will be attempting to do here is given any graph, you will be able to use whichever one of these two best suits the graph to solve to get to the equation. Okay? There'll be a time where I'll tell you you have to use the vertex form. There'll be a time I'll say you need to use the root form. And then in both cases, you need to change it to standard form at that point. Okay? Any questions about what we just did today? So it's very similar to yesterday. The only difference is instead of starting on the intercepts, we're starting with the vertex today. It's the only difference. All right? Okay, question 9 on page 197. The equation was given to us. A bus company charges $2 per ticket but wants to raise the price. The daily revenue is modeled by, so I can calculate my revenue. If I take minus 30 times x minus 6 squared plus 34,320. Where x is the number of 15-cent price increases and Rx is the revenue in dollars. What should the price per ticket be if the bus company wants to collect daily revenue of $30,000? Okay, first thing I want to do is I want to discuss what's happening here. X is the ticket price. Y in this case is my Rx, which is my revenue. So they start with $2. So the ticket price is $2. So I put 2 in here. Sorry, I don't put anything in there. The X value is going to represent the number of, sorry, I messed this up. Okay, the ticket price starts at $2, and they want to increase the ticket price. What they're saying that if they continue to increase the ticket price, it's going to go up. The amount of revenue is going to go up, but there's going to be a point where people are going to say, no, it's too much money, and then they're going to stop buying it, right? Okay, so X is going to represent the number of price increases of 15 cents. So the first time they do it, they're going to make it $2.15. And the next time they're going to do it, they're going to make $2.30. And then they're going to make it $2.45. All right? So if they don't increase the price at all right, they suspect that the revenue will be 6 squared, which would be 36. 36 times 30, or negative 30, and then add 34,320. So we could calculate what the revenue is. Then if I put one increase of 15 cents, it's either going to go up or down. I'm either going to make more money or I'll lose money. We're not sure why. So instead of doing this right now, what we're going to do is they want to make a revenue of $30,000. So what I want you to do right now is I want you to graph this. So use your Desmos right now and graph this equation. And I want you to first of all find out what the maximum amount of money, one, that they're going to make, and two, how much are they charging to make that amount of money. So I want you to graph this. So the first thing I want is I want the vertex. Is this graph going to open up or down?
Now,
Down. Therefore, I'm looking for the maximum amount of money I'm going to take in, right? So let's calculate our vertex.
Quite large.
Yeah. Well, think about it. 34,320 is the base amount of
You
revenue.
want to know the vertex?
I want to know what the vertex is. Yeah, Rowan.
6, and then 34,320. That's what I got.
34,000 what, sorry?
320.
320. There's my vertex. Okay. Has everybody got that vertex?
Yeah.
All right. Now my question to you is this. How much did they charge in order to get $34,320? How much did they charge?
$290.
$290?
I hope.
Do we agree or disagree?
Oh no.
Who can tell me how to find out the answer to the question I'm asking? Go ahead, Austin.
Well, I think that means that they have 6 price increases. So I did 6 times 0.15 and then added the regular $2.
He's absolutely right. Okay? This X value, if you read your question, is the number of 15-cent increments or price increases. So if you increase it 15 cents 6 times, that's an increase of 90 cents. So they're going to charge $2.90. And if he charges $2.90, he's going to end up with a maximum revenue of $34,320. Hello? No? We understand what I just did there.
Nope.
I do.
You don't. Okay, what part of it don't you understand? Can you get the vertex? $2.90?
Yeah.
This is increasing the price 6 times. Each time you increase it 15 cents. So 6 times 0.15 is 90 cents. It started at $2, now I'm charging $2.90. Okay? All right, now that wasn't what the question asked. The question said it wants to make $30,000. So right now you have a parabola. I don't know what it looks like. It looks something like this, right? In which this is 6 and 34,320. Agreed? So we need to find the amount in order that we can charge in order to make $30,000. So what I want you to do next is this. Put a second line on there at y equals 30,000. Because that's the revenue. And I should end up with two values, one here and one right here. And I want to know what both of those are.
-6 and 8.
Okay, so you said -6, so this is actually on the other side here?
Yeah.
Okay, so let me fix this graph a bit.
It's right, but Amy's is just not working out.
Okay, so this value right here, you said was what? -6 and 30,000, right?
18.
18 and 30,000.
And 18 and 30,000. Okay. So now, what does that mean?
But you decrease the plus like 15 cents, like minus 15 cents 6 times.
Right. So what would I actually be charging at this point here?
Like 1.10.
$1.10. Right? And then what am I increasing it by right here to get that?
18
18
times 0.15.
times 0.15. So what does that work out to?
So something quite worth.
What'd you get? $4.70. So if they either charge $1.10 or $4.70, I'm going to end up with a revenue of $30,000. Anything in between that means I'm going to make more than $30,000. Does that make sense as to how this question looks? You're going to do a bunch of this yet. So we want to make sure that we understand what's happening in this question. Okay? So to make more than $30,000, you need to charge a minimum of $1.10 or a maximum amount of $4.70. If I charge greater than $4.70, if I charge $4.85, that would be down here somewhere. So I wouldn't make $30,000. I'd start to lose money then at that point, right? So the best case scenario is this guy. Charge $2.90. You'll get a revenue of $34,320. Right here. Okay?
Would you ever do this question using your table?
Yeah, there's not this particular question, but yes.
Okay.
Yes, I would. Okay? So it says, what should the price per ticket be if the bus company wants to collect daily revenue of $30,000? And you have your answer. All right? Any questions this morning? Any other questions about this guy first?
No, not an answer.
Okay.
Yeah. Number 8 on 196, if you could.
You can't factor this? Is that your issue?
Yeah.
What's the product? Negative 30? Sum? Plus 1? What are the factors? What are the factors in negative 30 that give you plus 1? Come on.
-5 and 6.
What do you got?
-5 and 6.
I can never do these. It's always too hard. My brain just can't function.
Negative 5 and 6. Good for you. Austin?
I'm sorry.
What?
What I said yesterday,
You're gonna struggle with your multiplication table.
If you're gonna struggle with your multiplication table, you're gonna have troubles factoring.
Can you finish the question?
I can you?
Yeah.
Perfect, I don't need to.
Okay, well, this was a conversation in 5 minutes.
What are you supposed to do next, Emery?
And
I'm just gonna start by doing this. Right, and then what?
become multiples.
Yeah, but you, 2 sets of brackets first, right?
Yep.
So you put those in and then you take a common multiple out. I won't leave it, because that's a very doable question. Okay, was there any other factoring issues that you had yesterday? So like I said, you should be done. You should be done to the end of 197 by me doing that question 9. You should be done today. I'm giving you loads of time to do each section here rather than rushing through it. So I want to make sure that we get this. Those of you in pre-calculus, you're going to do a lot of this. So we got to make sure that we do it well now so that it's a lot easier for you when we get to pre-calculus. Okay? All right, so you should finish to the end of 201 today. Finish to the end of page 201. Austin, you get it to work out?
Yeah, thank you.
No worries. Yes, Brock. You may.
Oh, I was supposed to play the case was gonna be late.
Oh, man.
He's gonna be late, I just did not tell him. Here?
Yeah, honestly.
Not at the moment, no.